The next important thing which we are going to discuss is the notion of what we call a percentile. These days, with a lot of competitive examinations, most of the scores in competitive examinations are reported as percentiles. Percentile is different from percentage. What is a percentile? The sample 100% percentile is that data value that has the property that at least 100% of the data are less than or equal to it, and at least 100 into 1 minus p% of the data are greater than or equal to it. So now if p is equal to half, 100 into p is 50% of the data, 1 minus p is half, so 100 into 1 minus p is also 50% of the data, and we have already seen a measure which says that 50% of the data is less than the value and 50% of the data is greater than the value, and we call this as the median of a data set. So the 100 into half or the 50th percentile is the median of the data set. So to demonstrate it using a figure, you can see that 99th percentile would have 100 into 0.99, that is 99% of the data is less than it, but 1% is greater than it. Similarly, P1 says 1% is less than it, whereas 99% is greater than or equal to it. So the concept of the percentile tells us that value in the data set below which I have 100 into p which are less than or equal to and 100 into 1 minus p which are greater than or equal to. Now, if two data values satisfy the condition, it is the arithmetic average of these values. We have already seen how to compute the median when I have odd or even number of observations. How do I compute a percentile? There are many algorithms to compute a percentile. I now present with a very simple algorithm to compute a percentile, which is also very commonly used algorithm. So suppose I have a data of size n, that is I have n observation. I want to find out what is my sample 100p percentile. What I do is I arrange the data in ascending order. That is my first step, similar to what we did when we computed a median. Once I arrange my data in ascending order, I find out what n into p is. So now let me give you the analogy of what we did with respect to the median. So I arrange the data in ascending order. This is something which I did for the median also. Remember p equal to half. So I check what is n by 2. If n is even, I know n by 2 would be an integer. If n is odd, I know n by 2 is not an integer. So if np is not an integer, I determine the smallest integer greater than or equal to np. That is the value in that position is the sample 100p percentile. If np is an integer, then I look at the average of these values in positions np and np plus 1. So what did I say? If n by np is not an integer, for example, if I look at n by 2, suppose n is equal to 5, my n by 2 is 2.5. The smallest integer greater than this is 3. So you saw that in a data set of 5 points, the third value would give me my median. So that corresponds to my algorithm here. I repeat, if np is not an integer, let n be equal to 5, p equal to half, n into p is 5 by 2, which is 2.5. It is not an integer. The smallest integer greater than this is 3. So the value or the data which is in the third position, because I am already arranging my data in ascending order, will give me the sample 100 into p, or the 50th percentile, or the median. But if NP is an integer, so now let n be equal to 6 and p equal to half. My NP is an integer which is equal to 3. Then what do? I look at the average of the value. So the third plus the fourth data value. That's what we do. And I have 6 data points, x1, x2, x3, x4, x5 and x6, which are arranged in ascending order. Then you know that x3 plus x4 by 2 is my median. This is how we define. So I do the same thing. If NP is an integer, I look at the average of values in positions NP and NP plus 1. So let's look at n equal to 10. I have my data. I again arrange my data in ascending order. This is the same data we have been using. So I have arranged my data, my n equal to 10. So for p equal to 0.1, my n into p is 10 into 0.1, which is 1. It is an integer. So going back to your algorithm, I need to look at the value which is NP and NP plus 1. The first value, NP is 35, NP plus 1 is 38. So 35 plus 38 by 2 is 36.5. This is my 100. So you look at 0.25, 2.5, it is not an integer. So the third value, which is 47, that gives me the 25th percentile. 0.5, we have already seen 63.5, again 61, which is my fifth value, 1, 2, 3, 4, 5, 61 plus 66 by 2, that would give me 63.5. 0.75 is again a fraction. So you can see that when I have 0.75, it's 7.5. So the eighth value, so this is the first, second, third, fourth, fifth, sixth, seventh and eighth. 9, 10, 8th value is 68. 68 is the 75th percentile. The 100th percentile is the maximum, which is 79. So this is how you compute percentiles, and the example shows how to compute percentile for the given data set. However, Google Sheets uses a percentile function and a slightly different algorithm to compute percentiles. So now we will demonstrate how to compute a percentile in a Google Sheet. So let's go back to this Google Sheet. I have the following data set, the same data set which has been given in ascending order. Okay, this is the data set which I have. I have written the data set in ascending order. In a blank cell, enter percentile and the data. So I just go here, I type out what is the percentile. So if I am looking at this data set, I look at the percentile. So B2 to B11, that is my data set, with C2. C2 is 0.1. So this gives me what is a percentile. So for example, if the data we are interested in 90th percentile, I put a 0.9. If I am interested in the 10th percentile, I put a 0.1. So you can see that 37.7, the 90th percentile, I am putting it here is 70.9, the 100th percentile is 79. So you can see this is how we have computed, or the Google Sheet computes it. Again I repeat, the way Google Sheet you do is choose the data, that is B2 to B11, that is the data which I want to compute the percentile for, and C2 is 0.1, 0.225 will give me the 25th percentile, this gives me the 10th percentile, 54.7 will give me the 30th percentile. 0.9 gives me 70.9 is the 90th percentile, and 79 is the 100th percentile. Notice that the percentiles need not be part of the data set. What you notice immediately is these percentiles which Google Sheet percentile function gives us is different from the for the same data set. It is different. Here I got my 10th percentile to be 36.5, whereas the Google Sheet gives me 37.7. So the algorithm that Google Sheet uses, it's not that this is wrong and that is right, but the algorithms used, as I mentioned earlier, the algorithms used are different. So what is the algorithm a Google Sheet uses to compute percentile? So first it arranges the data in ascending order. So I have the data. These are x1, x2, x3. These are the ranks. The data is arranged in ascending order. That's what we have done here. The data is arranged in ascending order. The second step is, for any observation, xi is denoting the ith ordered value. Find the rank using the following formula. So the rank is percentile into n minus 1 plus 1, where n is the total number of observations. So let's look at it. N in this case is 10. 10 minus 1 is 9. Okay. Percentile into n minus 1. So for example, if I want the 25th percentile, I put 0.25 into percentile is 0.25 into 10 minus 1. So I have 0.25 into 9 plus 1, I get a 3.25. Is that clear? So you can see that here what I have done is computed the rank using that same formula. So what is this formula? It is C2. C2 is your percentile into n minus 1, which is my 9 plus 1. So this is the data. So percentile into, so I am computing the rank of each of these data sets. So the rank here is 1.9, 3.25. We have already demonstrated how I got this 3.25. For each of these ranks, I have an integer part and I have a fractional part. If the rank is 1.9, the integer part is 1, the fractional part is 0.9. For 3.25, the integer part is 3, the fractional part is 0.25. Okay. So for each one of them, I have an integer part and a fractional part. So in the third step, I split it into an integer and fractional part, and that's what we have done here. For the rank, I have split it into an integer part and the fractional part. For every rank, first we compute the rank, then I split the rank into integer and fractional part. Once that is done, I look at what is I compute the ordered data value corresponding to the integer part rank. So what do I mean by this? For 3.25, the integer part is 3, the fractional part is 0.25. Compute the ordered data value corresponding to the integer part rank. The integer part rank is 3. And you can see that the ordered data corresponding to this integer part rank is 47. Again, for this 25th percentile 3.25, integer part is 3, the fractional part is 0.25. So what I do is I look at computing, or I look at that value which is corresponding to the integer part rank, which is 47. That's what we have done here. Okay. So I have this element value. So 1, 35. The integer value corresponding to 1 is 35. Corresponding to 3 is 47. 4 is 58. 5 is 61. 6 is 66. 7 is 68. Again here I have the integer part which is 8, again it is 68, with 9 it is 70, and with 10 it is 79. This is the value which corresponds to the integer. So 1, you can see it's 35, 3 it is 47, and so forth. Once that is done, in the fifth step, you find out what is the percentile value. The percentile value is the xi, which is 47, plus the fractional part. Remember, the 25th percentile was 3.25. The fractional part was 0.25. The integer part was 3. The value corresponding, or the order corresponding to x3 was 47. I take the fractional point, which is 0.25, and I look at xi plus 1. What is xi plus 1? It is 58. So I look at xi plus 1, which is 58, minus xi, which is 47. So 47 plus 0.25 into 58 minus 47 is 49.75, and that's what I have here. Okay. In the first thing, I have again element value is 35, element value plus 1 is 38, which is x2. x2 minus x1 is, what I have is 2. I multiply that with my fractional part, that's what you do here, which is 0.9. I add that and I get a percentile function, which is 37.7. So I have 33 into 0.9, which is 2.7, 35 plus 2.7 is 37.7. So you can see that this column I gives us the percentile value computed using this equation, whereas column J gives the percentile value computing the percentile function of the Google Sheets. And we can see that both of them are exactly the same. So why are percentiles mentioned when we talk about the measures of dispersion? As I earlier mentioned, a very important measure is called the quartile. The sample 25th percentile is called the first quartile. The 50th percentile we already know is the median or the second quartile, and the sample 75th percentile is called the third quartile. So I have Q1, Q2 and Q3. This is referred to as the first quartile, or in some books as the lower quartile. This is the third quartile, or referred to as the upper quartile. This is the median or the second quartile, which is already we have seen is the median. Okay. Now, when I have the quartiles in fact break up a data set into 4 parts. So if I have this as my data set, I know already the median breaks up a data set into 2 parts. The first quartile or the lower quartile, I have a upper quartile, this is Q2. This breaks up, so I have the least, this is the minimum, I have the maximum, I have the first quartile, the second quartile, the third quartile, also referred to as a lower quartile, and the upper quartile. Okay, it breaks up the data set, so I have part 1, part 2, part 3 and part 4. So you can see that the quartiles break up an entire data set into 4 parts. 25% of the data lie here, 50% lie here, 75% lie here, and entire data set lies between minimum and maximum. Okay. So why are these again an important measure? If you look at it, any descriptive statistics, most of the summaries are given by what we refer to as a 5-number summary. The 5-number summary includes the minimum, the first quartile, the median, the third quartile and the maximum, as we are given here. So this 5-number summary is a very good way of summarizing a data set. The interquartile range is a very important measure of dispersion, which we have already seen. The range is the difference between maximum and minimum. The interquartile range is the difference between the third quartile and the first quartile, and this is referred to as the interquartile range. So, for our example, the first quartile was 49.75, the third quartile was 68, the interquartile range is 18.25. So, the interquartile range is also a measure of dispersion. So, what we have seen so far was how to define percentiles, how to compute percentile, what is the definition of a quartile, the 5-number summary, which is very, very important in many descriptive statistics, and interquartile range, which is a measure of dispersion. The interquartile range, so this, if you look at Google Sheet, the quartile function with the array and 1, the lower quartile is the first quartile, gives me the lower quartile. The quartile function with 3 gives me the upper quartile, and the difference between the upper quartile and the lower quartile gives me the interquartile range. And we can see that the quartile function, if I put 2, gives me the median, which you have already seen is 63.5. 3 gives me the upper quartile. So, this is my Q1, this is my Q3, and this is my IQR, or my interquartile range. So, a summary of this module, where we summarized numerical data. What you should be knowing at the end of this module is, we first started by looking at frequency tables. We looked at discrete data, where each data point was considered as a category or a class. Then we looked at group data. We defined what were class intervals. We defined what was lower class limit, upper class limit, and we saw how to construct the frequency tables for both discrete and grouped data. We followed it with histograms. Again, here we assumed class intervals were of equal length, and we saw how to construct histograms using Google Sheets. The stem and leaf plot, we also demonstrated how to come up with a stem and leaf plot for an example data. Then we moved on to numerical summaries. We started with the measure of central tendency. Although we have looked at mode and median in the earlier categorical data module, but then now we introduce a very important measure called the mean. What we observed was mean was very sensitive to outliers, is something which we saw. And then we saw what would happen to each of these measures of central tendency if you add a constant and if you multiply with a constant. The reason is, it always helps us to know what would happen to the measures whenever we manipulate the data, and the way we manipulated the data here was to add a same value or multiply it with the same value. Then we moved on to look at measures of variability or dispersion or spread. We started with the measure range. Again, we saw that the range is extremely sensitive to outliers. We showed this through, illustrated it through an example. Then we talked about variance. We also defined the population variance and the sample variance, but we stuck on to the sample variance. At this point of time, we said that all these measures take the same units of your original data, whereas variance takes the units of squared units of the original data. Hence, we define a measure which is standard deviation, which is square root of the variance, which takes the units of your original data. Then we went on to percentiles. When we discussed about percentile, we introduced what were percentiles. Then we introduced important percentiles, namely the 25th percentile, the 50th percentile and the 75th percentile. We call this the first quartile or the lower quartile. The 75th percentile is the third quartile or the upper quartile, and the 50th percentile is what we already have seen as the median. The difference between the third and the first quartile is what we refer to as the interquartile range, and we see the interquartile range is a measure of dispersion. So with this, we come to the end of the discussion on how to come up with numerical summaries for a single variable. What we are going to see next is the association between two variables. So far, we have looked both in the categorical case and the numerical case, measures of graphical summaries and numerical summaries of a single variable. What would happen when I have more than one variable? So we look at having two variables. We start with having two categorical variables. Look at how we look at the association between two categorical variables. We look at association between two numerical variables, and then we look at association between a categorical and a numerical variable. So this is what we are going to do next.